Use the converse of the Pythagorean theorem. First, let's talk about what a converse is. If you had this in logic, then you already know that converse is the backwards version of a statement. So if I have a statement like, if I'm a girl, then I'm female, the converse of that statement would be, if I'm female, then I'm a girl. So, our converse of the Pythagorean theorem is, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Did you understand that? Because usually we say, okay, if we have a right triangle, then a squared plus b squared equals c squared. The converse says, if a squared plus b squared equals c squared, then I have a right triangle. Okay? So, let's look at example 1. We need to verify right triangles. Tell whether the given triangle is a right triangle. Okay, we have 6 and 9 for our leg lengths, and 3 times the square root of 13 for our hypotenuse. So let's check and see if that makes a true Pythagorean theorem. For some reason, this book always flips it. I go ahead on my papers and just do it a squared plus b squared equals c squared. So let's come over here and do that. So a squared is 6 squared, b squared is 9 squared, and c squared is 3 times the square root of 13 squared. Now how do I write that? If I just put the 2 up here, it looks like just the square root of 13 should be squared. I need to put this in parentheses so the whole thing will be squared. Okay, 6 squared is 36, and 9 squared is 81. Now what's this squared? Well, 3 squared is 9. What's the square root of 13 times the square root of 13? That's just 13. So now I need to multiply out 9 times 13. That equals 117. 36 plus 81 equals 117. So this checks as true. So this is a right triangle. Now, let's look at B. (16 squared plus 24 squared), does it equal 29 squared? So we have, let's see, 576 for this, and 256 for that, plus, and does that equal 841? No, when we add this side together, or these sides, we get 832. And that does not equal 841. So this triangle is not a right triangle. We can use the converse of the Pythagorean theorem to also tell us something else about triangles. We can tell whether they're acute or obtuse. Let's draw a triangle. First, let's draw a right one. We know that the longest side has to be C, and the other two sides are A and B. Now, if I drop the right angle a little bit and make it, let's say about 70, then what happens to this side length, C? Well, it gets a little bit shorter, doesn't it? So now, when we do our Pythagorean theorem, and we say a squared plus b squared, does it equal c squared? We'll say no, of course not, it's not right anymore. But what does it equal? Well, these two, will they be bigger or smaller than c? Well, they'll be bigger, won't they? So if a squared plus b squared is bigger than c squared, then we know that this triangle is acute. Okay, let's draw another one, except this time let's draw it obtuse. So our right angle now gets big and obtuse. So we'll have a squared plus b squared equals c squared. Now, that of course won't be true because it's not a right triangle, but what will we know? Well, a squared plus b squared this time will be smaller than c squared. And if they're smaller than c squared, we know it's obtuse. So bigger, acute, equal to right, smaller, obtuse. You need to have these memorized because I tend to get them mixed up. So don't let me mix you up, and you need to have them memorized. One of the reasons why I tend to get it mixed up is because this book flips it. They'll put the c squared first. But that's okay, because we still know that we can turn around and say a squared plus b squared is bigger than c squared. And that means that it's acute. And then if a squared plus b squared is smaller than c squared, we know it's obtuse. Now, we don't know exactly, we can't tell the lengths of the side this way. So we can't say I have an obtuse triangle with sides x and 2 and 3. What's the x? We can't say that it's definitely some number, but we can say it's obtuse. So let's look at example 2. Now, can segments with lengths 2.8, 3.2, and 4.2 form a right triangle or form a triangle? If so, would the triangle be acute, right, or obtuse? Okay, first we need to talk about the triangle inequality theorem. Triangle inequality theorem says that 3 lengths can make a triangle if any 2 of them, when you add them together, are longer than the last one. So, step 1, what they did was they just took every possible combination and added it together. And they said that 2.8 plus 3.2 is 6, and 6 is greater than the last length, 4.2. Or we can take the 2.8 and the 4.2 and add up to 7, and 7 is greater than 3.2. Or we can say that 7.4 is greater than 2.8. So, yes, these 3 lengths can make a triangle. Let's come over here and write one that wouldn't. Say we had length 10 and 12 and 1. Would that make a triangle? Well, 10 and 12 is bigger than 1, but 1 and 10 is only 11, and that's not bigger than 12. So see if you can picture it. Here's the 12, and then here's my 1, and if I put my 10 up here, it wouldn't quite reach all the way to make a triangle. So this would need to be at least, not even 2, because 12 is the same as 12, but this would need to be over 2, like 2.1. Okay, let's classify the triangle. So we have a squared plus b squared. What is a squared plus b squared in this triangle? Okay, first we have to decide which side is which. So the longest side we always call C. So the longest length in here is a 4.2. So we're going to substitute the 4.2 in for the C. And then remember, I flip it around, so I'm going to put 4.2 over here. And then a squared plus b squared would be 2.8 squared plus 3.2 squared. Okay, 2.8 plus 3.2 squared on your calculators will be 18.08. And then 4.2 squared is 17.64. And then 18.08 is bigger. So what does it mean when a squared plus b squared is bigger than c squared? That means that this is an acute triangle. Okay? If a squared plus b squared together is bigger than the third side. Okay, example 3. Example 3 is just a interesting way to make sure something is straight up. So if you're putting a pole in the ground, how do you know when it's perpendicular to the ground, whether it makes a right angle or not? Well, the easiest way to do is measure 3 feet up on the pole and then 4 feet out. Then take a measuring tape and measure from the 3-foot point to the 4-foot point. And it should be exactly 5 foot because that makes the right triangle. And if not, you kind of pull that pole around in the concrete until it does. Now, that tells us whether it is right going one direction. Now we need to know whether it's leaning the other way. And so you do it again on the other side. 3, 4, 5, and you make sure it's good. So I don't think you really need to know anything about that yet. Let's come down here and look for methods for classifying a triangle. Okay, so this is a fairly confusing little topic. So let's go ahead and they put it in a box and just repeat it. So here we go again. If a squared plus b squared equals c squared, then it's a right triangle. If a squared plus b squared together is bigger than c squared, then we have an acute triangle. If a squared plus b squared together is smaller than c squared, then we have an obtuse triangle. All right, let's look at. Okay, checkpoint. Tell whether the triangle is a right triangle. Now remember, on 1, when you're taking this side and squaring it, we need to put it in parentheses and square both the 2 and the square root of 10. Same thing for number 2. Okay, so 3 can segments with lengths of 6.1, 9.4, and 11.3 form a triangle. So make sure to add 2 of them and see if they're over the, if the measurements of the 2 smallest are over the biggest. So it can form a triangle. Then square the 2 smallest and see if it's bigger, smaller, or equal to the third side. Okay, in example 4, don't worry about example 4. Let's just mark that one off.